As a review, let's talk about fractions quickly. If I had 5 over 2 and I wanted to add to that 6 over 7. Can I add those the way they sit now? Why?
Because they're unlike denominators.
They are not the same denominator. I need a common denominator. And in fact, what I'm going to do is I'm going to find the least common denominator, which happens to be the least common multiple between the two, right? And I'm breaking this way, way down because you're going to have to understand this. Just like when we did polynomial long division and you had to understand regular long division, you need to understand really, really basic on adding and subtracting fractions to understand the rationals. So when we talk about least common denominator, we're really talking about the least common multiple of 2 and 7, right? So when I think about 2, I think about 2, 4, 6, 8. And for 7, I'm talking 7, 14, and I can stop because there's the smallest one that they have in common. Okay? And then what I do is I force the denominators to look like that. I force them to be 14. So the first fraction would need a what?
7.
Needs a 7, so I'm going to times by 7. This one would need a
2.
times 2. So the first fraction becomes 35 over 14, and the second becomes 12 over 14. And now because the denominators are the same, I can add the numerators together, right? Right.
Yes.
Okay. Are we good on that?
Yes.
One more thing before I actually jump straight into the rationals is, do you remember how to do a prime factorization?
Like the tree thing?
Like the tree thing where we keep breaking it down. For instance, if I had,
This is like first grade.
let's say 18. Okay. Let's think about how we could break 18 down. 9 and 2. And then you look at the 9 and the 2 and you say, can I break any of those down again? And the answer is yes. I can break the 9 down into 3 and 3. So the prime factorization of 18 would be 3 times 3 times 2. Right? Or 3 squared times 2. Right? Are we all okay on that? Because we're going to have to use a little bit of that as we find least common denominators. Any multiple would work for the denominator, but then if you don't use the least one, you end up having to go through and simplify your fraction at the end, and we don't want to do that, so we want to use the least common. Is it hot, Ben?
Yeah.
Okay. Everybody okay so far before we jump in? All right. Let's start with an easy one then. Let's say I had... Actually, before we do it, let's practice finding a least common multiple. Let's say I had 4x squared minus 16, and I had 6x squared minus 24x plus 24. What I want to find is, I'm going to pretend like these are in the denominators of fractions, and I need the least common denominator. So what I'm going to find is the least common multiple.
2x.
Multiple means I'm multiplying. So what I have to do before I start is everything has to be factored. Okay? Any numbers in front, like GCFs, need to be prime factorization. Okay? Prime factorization. So, looking at the first one, remembering my steps that I do when I factor, the first thing I need to do is take out what? 4. What's left, Ben, when I take out 4? X squared minus 4. Can I factor that any further? Yes. How?
X plus 2x.
X plus 2x minus 2. I'm going to change this 4 also. What's the prime factorization of 4? 2 times 2. And now I've got x minus 2, x plus 2. This is completely factored. It is broken down as far as I can break it down. Do we all agree?
Yes.
So it has 1, 2, 3, 4 pieces being multiplied, yes?
Yes.
Okay. How about this one? Take 6 out. What's left? Now what? Put it in a little box or factor it. This has got a leading coefficient of 1, so it's a pretty easy factor. What multiplies to 4 and adds to 4? Same signs. Negative 2 and negative 2. So I got x minus 2. How about the 6 out front? Do I need to do anything with it?
2.
How? 2 and 3. Are we okay so far?
Did you write that as like x minus 2 squared?
This is 2 times 3 times x minus 2, x minus 2.
I know, I'm thinking.
Right now, leave it written out like this so you can see. I want you to actually see how we form the LCD. Now, you're kind of expanding it. All right, so now to find the LCD, what I want to do.
Wait, how come there were 3 x's in the top one and there's only 2 there?
What?
There's 3 x's in the
There's 3 x's in what?
that. X squared and then x. They're the.
Yeah, I put it in the box.
Oh.
If you foiled that back out, it would come back out. All right. When we talk about a least common multiple, okay, every factor in each piece here has to be included in the least common multiple. But you don't want any repeats. In other words, it's got to have 2 2's, it's got to have an x minus 2, and it's got to have an x plus 2. It's got to have at least 1 2, but that one's going to make me have 2. It's got to have at least a 3. This one's got 2 x minus 2, so I need to have at least 2 in the LCM. This will make more sense whenever I write it down. Here's what I do. I generally write the first and then include any missing factors from the second to find the LCM. Missing. So I take the first one, 2 times 2, x minus 2, x plus 2. Because that entire piece has to be included in the LCM. Okay? Now I come over here. I need a 2. Does it have a 2?
Yeah.
Yes, it has a 2. There's no sense in writing that again. I need a 3. Does it have a 3? No, I need a 3. I need 2 x minus 2's. I got 1, so I need 1 more. So now the question is each of these completely included in this? In other words, are all the pieces of the first one in here, and are all the pieces of the second one in here? Yes. So now I can put everything together. So I can say, and now whoever asked all day. Now is when I can put everything together. So 2 times 2 times 3 would be 12, right? 2 times 2 is 4 times 2 is 3 times 3 is 12. I've got 2 x minus 2's and an x plus 2. So that is my least common multiple of those two. Does that make sense to you? This is by far the hardest part of adding and subtracting the fractions, is finding that LCD, which is also an LCM.
Can we do another?
Yes, let's do another. So let me find a good one. Well, that was a good one, because it was kind of tough.
Yeah, exactly. Yeah.
Oh, don't forget this for the test, because this is about a third of the test.
That's what happened with factor.
Who is sharp?
Okay.